So first, our topic was Thomas, Aristotle, and alchemy. And this topic, they are more focused on the atomism, non-atomistic views, growth of alchemy across different civilizations, and the Western alchemy. Leucippus and Democritus highlighted here that the atomism is made of much smaller things that cannot be changed nor divided. In this topic, I also learned the views of the Greeks about the non-atomistic, which is the Anaxagoras, Empedocles, Plato, and Aristotle, which is they told us about the elementary natural substances and also the four internal and unchanging kinds of matter, which is the fire, air, water, and earth, and also the essential qualities, which is the hot, dry, cold, and wet, and the growth of alchemy across different civilizations. Next is the growth of alchemy across different civilizations. First, alchemy, a science that was used in the Middle Ages with the goal of changing ordinary metals into gold. Next is the Au gold. Au gold is from the Arabic alchemeia or art of transmuting. Also the Mesopotamians matches metal with the heavenly bodies such as sun and moon. And the Egyptians adapted techniques from the Mesopotamians and perfect use of bronze, dye, and glass. And also here we're going to know about the Chinese. Chinese had their own process from metalwork and ceramic materials. They also focus on finding materials, plants, and substances that could prolong life. And also the Chinese had their own process for metalwork and ceramic materials. They also focus on finding materials, plants, and substances that could prolong life. Also, some of the substances that discovered in Chinese medicine have been found to have actual positive effects. And also the Indians. They had a kind of alchemy which is called Rasayana that look at different substances and practice for Vedic medicine. Our next topic was the structure of the atom. And this topic is talking about the beliefs of the scientists about the atom. In Dalton's atomic theory, I've learned that the elements are made up of small and visible particles called atoms and that the compounds are composed of atoms of more than one element. The second was John Joseph Thomson. He is talking about the cathode rays. That cathode rays are streams of electrons observed in vacuum tubes that if an evacuated glass tube is fitted with two electrodes and a voltage is applied, it is observed that the glass opposite the negative electrons glows from the electrons emitted from the cathode. Next is Ernest Rutherford. He postulated the non-clear structure of an atom and talked about the alpha and beta rays, which is the two kinds of radiation based on their penetrating power. Next is Niels Bohr. Shows about the atom as a small, positively charged nucleus surrounded by the orbiting electrons, and explained that electron can be moved into different orbits with addition of energy. When the energy is removed, the electrons return back to their ground state, emitting a corresponding amount of energy. Next, and Werner and Eastern talks about quantum model has a nucleus and has the energy levels of quanta and explains why electrons don't fall into the nucleus. Electrons don't fall into the nucleus because electron as an atom are in circular orbits around the nucleus. It is the attraction between positive charge of the electron that holds the electrons in these circular orbits. And James Chadwick talked about on how he worked on radiation emitted by beryllium that took the form of the particles heavy enough to displace protons. These particles were as heavy as proton, but they needed to have a neutral charge that would allow them to smash into the nucleus without being repelled by electrons or protons. Our next topic is corpuscles to chemical atomic theory. First is Robert Boyle. He was the one who had idea of the corpuscles were certain primitive and simple of perfectly unmingled bodies that were individual and whole. And Anthony Lavoisier, the one that disproved the principle to lose a substance of negative weight, and talks about the air is not an element because air is made up of the different gases like hydrogen, carbon dioxide, and oxygen mixed together. He was also the one who wrote the first chemistry textbook and the father of all chemistry. Next is John Dalton. He talked about the gases and all chemically inseparable elements are made of atoms. And also we have the three fundamental laws, which is Anthony Lavoisier's laws of conversion, Joseph's law of definite proportions, and John Dalton's law of multiple proportions. First is the law of conversion. As an energy states that energy can neither be created nor destroyed, only converted from one. This means that a system always has the same amount of energy unless is added from the outside. Next is the law of constant proportion. That chemical compounds are made up of elements that are present in a fixed ratio by mass. This implies that any pure sample of the compound, no matter the source, will always consist of the same elements that are present in the same ratio by mass. Next is law of multiple proportions. The ratios of the masses of the second element that can combine with a fixed mass of the first element will always be ration of tiny whole numbers if two elements produce more than one compound. Next is the atomic mass. It's the sum protons and neutrons of a single atom. That is the atomic weight, which is the total weight of an atom is called the atomic weight. It is approximately equal to number of the protons and neutrons with a little extra added by the electrons. Next is Joseph Luzak. He was the one who determined that oxygen gas was made of two atoms of oxygen and took the form of a molecule. Next is Amedeo Avogadro. He states that equal volumes of gases under the same conditions of temperature and pressure will contain equal numbers of the molecules. And the last one is Dmitry Mendeleev. He was the one who published a periodic table of elements that ordered elements according to their atomic weight. Our next topic is structures, properties, and uses of matter. First, the intermolecular forces. Is forces of attraction between unlike charges, particularly positive and negative ends of the molecule that occur between molecules. The attractive or repulsive forces that arise between the molecules of a substance. Next is the properties of substance. First, the solubility. Solubility is defined as the ability of a solid substance. Next is the boiling point. Boiling point temperature at which the vapor pressure and the atmospheric pressure. Next is melting point, is solid is going to become a liquid. Next is surface tension, measured as the energy required increasing the surface. Next is viscosity. The viscosity is the resistance of the liquid to flow. Next is the vapor pressure. Vapor pressure is the pressure exerted by a substance. And next is the volatility. Volatility is the substance that vaporizes. Next is the London depression forces. London depression forces are the type of the intermolecular force acting between atoms and molecules that are normally electrically systematic. Also, London dispersion, named after Fritz Wolfgang London, a German physics and professor at Duke University. Next is a dipole-dipole force. Dipole-dipole force is an interaction between a polar molecules and also a attractive forces between the positive end of the polar molecule and the negative end of the another polar molecule. Next is the hydrogen bond. Hydrogen bond occurs specifically between a hydrogen atom bond to either an oxygen, nitrogen, or fluorine atom. This is also a strong force between attraction of the molecule. Next is the ion dipole force. Ion dipole force is attractive force between ionic molecules and the polar molecules. And these are the two types of the ion, which is the cation. The cation is when you give an electron. Next is the anion. Anion is when you receive an electron. Next is the application of a IMFA. First is the medical devices. Medical devices adhesives are used extensively in the medical world for simple plasters to achieve medical applications. Next is construction materials. Example of this is the construction or engineering materials. Next is sports equipments. One of the used materials to build a sport equipment is carbon fiber. Next is electronic devices. And the area of electronic, the classic joining technique of soldering of being the increasingly replaced by bonding in the order, for example, to connect highly integrated components with each other in a stress-free way and without the need to use excessive heat. Next is the household materials. Our next topic is coagulation theory and chemical reaction rate. First is the physical change. Physical change are changes affecting the form of a chemical substance but not its chemical position. Next is the chemical change. Chemical change, it combines with another substance for a new substance. Next is the collision theory. Collision theory states that the rate of a chemical reaction is proportional to the number of collision between reactant molecules and also states that reacting substances must come into collide activation energy and facing the correct way. Next is a chemical reaction. Chemical reaction leads to the chemical transformation of one set of chemical substances to another. Next is a chemical equation. Chemical equation is a symbolic representation of a chemical reaction in the form of symbols and chemical formulas. And the condition is particles must collide. Next is upon collision, orientation must be correct. The last is energy required to break the bonds must be enough. And these are the factors. First is activation energy. The activation energy is required for chemical reactions to proceed, forming the product in a chemical reaction. Next is nature and concentration of reactants. Nature is a phase of matter, its kind, its nature factor since it has its own identity and properties. Next is nature of concentration, reactants, and concentrations is the amount of the substance per unit volume. And fourth is the temperature. Temperature is higher temperature means higher kinetic energy. Next is the surface area and particle size. Is the sum of the exposed regions of a substance like solid and liquid. The last is the presence of the catalyst. Presence of the catalyst is that increase the rate of a chemical reaction. Our last topic is a source of energy. Belong of the source of energy is the kinetic and potential energy. The kinetic is to do the work and the potential is to address. And the topic that belong to the kinetic and potential energy is the power plant. Power plant, an industrial facility that generates electricity from primary energy. Next is the energy. Energy is a substantially used primarily energy flow for electricity generation is to hydroelectricity by using water. Next is renewable. And the topic that belong to the renewable is first is the geothermal. Geothermal utilize the heat energy from the Earth's crust, and energy is less of an environment hazard compared to the fossils, and also produced by the heat of the Earth's molten interior. Second is the hydroelectric. Hydroelectric is to delivered from the energy of falling or moving water. And also the turbine convert the kinetic energy. The example of the hydroelectric is the run of river or dam. Third is the wind power. A wind turbine uses wind to produce electricity. Fourth is the solar cell. Solar cell is used in electric powered technologies, can also use the sunlight for energy and also depended on the cycle of the sun. Lastly is the biomass. Biomass, organic matter from plants and animals. It contains methane or the natural gas. Next topic is non-renewable sources. First is the fossil fuels, which is contained the coal, oil, and gas are fossil fuel. Lastly is electronic chemical, which is the use of batteries. A battery is a device that stores chemical energy and convert it to energy electrical. The example of the electrochemical is the Galvani and the Volta.